about challenges of deep learning training task on existing system. In running large scale deep learning training task on cluster, several performance challenges are incurred, 5 of which are addressed by Diesel Flush. First one is metadata access scalability. Accessing numerous small files in a distributed file system poses a metadata intensive workload. Existing systems have two metadata storage designed both with drawbacks. Separate metadata and data servers hinder scalability, while system combining metadata and data on storage server slow down file listening operation common in deep learning task. Vulnerability of global caching system. Vulnerability of global caching system. Global in memory caching system like memcached cluster aim to accelerate file reads but suffer from drawbacks. Node failure can disrupt caching, leading to cache transing and reduce performance due to file reads in random order. The reading procedure also takes considerable time on cluster when dealing with large numbers of small files. These are the challenges. And also when third one is slow shuffled access of small file. Deep learning training typically read datasets epoch with randomly shuffled file orders. This shuffled access pattern significantly hampered output performance as shown in the table, but I have not included that table. But where in their paper they have one table where they represent this input output performance and different, where large read block size significantly outperform smaller one. Diesel where large is in table result. What is the table result? Where large read block size significantly outperform smaller ones. Diesel Plus introduced a chunk-wise shuffle methods to enhance file access performance. And CPU-intensive image decoding. Existing systems such as Jeparent employ GPU-assisted image decoding. However, CPU-based bit-by-bit scanning remains time-consuming in deep learning tasks. Repeated scanning of boundaries and the lack of overlap in time between CPU scanning and GPU decoding handling hinder throughput. An online ROI method is proposed to reduce image decoding workload. Expensive data movement. Data transfer between machines incurs significant cost. Cross-machine communication often relies on remote procedure calls (RPC), remote procedure calls. Reducing network package size can notably improve RPC performance and reduce latency. Online ROI cropping helps mitigate RPC cost as deep learning framework access files from Diesel Plus caching layer via RPC calls. These challenges highlight the need for optimized solution like Diesel Plus to streamline deep learning training task on cluster. And here is some related work. Optimization on metadata management. Several existing storage systems employ various techniques to optimize metadata management. Table apps and index fs and delta fs use the log structured merge tree SLM tree for metadata management, outperforming local file system on metadata intensive workload. A composite file system file composite file system groups CFF group multiple files into a single metadata entry, reducing metadata overhead. GRFs stores metadata in high performance distributed database called HBase, while HOPFS replace the in-memory metadata service in HDFS with distributed metadata service built on new SQL database. LocoFS decoupling directory content and structure into flattened records in separate key value database. Metadata caching is widely used in existing system with system like Lustre, GPFs and SAPE, employing caching to speed up file lookup and directory traversal. In contrast, Diesel Plus uses distributed key value database for metadata storage, offloading metadata computation to GPU nodes, and introduces metadata snapshot to serve all metadata operation locally, bypassing the bottleneck on metadata queries and network communication. And distributed storage caching for deep learning. Existing solution for distributed storage and caching in the context of deep learning include FineStore, Deep IO, DLFS, and Quire. FineStore optimize database into chunks and distributed them to multiple nodes, but has faced stability issue with some deep learning frameworks. DeepIO implemented an in-memory storage system co-located with training application and employs memory-based shuffling and entropy-aware overriding techniques. DLFS extend DeepIO to NVMeOF device. Quicker is a Quire is caching system that improves the reading speed of deep learning training tasks through secure hash-based file lookup, coordinated eviction, and benefits aware techniques. However, these solutions often focus on either the caching or the storage layer, missing opportunities for comprehensive input-output optimization. In contrast, Diesel Plus offers an all-in-one system compassing dataset storage, caching, and processing with multi-level optimization for deep learning training tasks. Efficient image decoding pipeline for deep learning training. DL Booster folds offloads JPEG decoding to FPGA accelerators, achieving speed up to speed ups of 1.35x to 2.4x. However, FPGA accelerators require expertise in low-level programming language. Diesel Plus take a more widely applicable approach by optimizing existing deep learning pipeline on GPUs. So these are the challenges, and these are the related work on this Diesel Plus on Diesel Plus systems.